In this video, we will learn how to convert decimal numbers in any given base to base 10. The process of converting decimal numbers in any given base to base 10 is similar to that of whole numbers. The only difference is that while we'll assign positive numbers to digits on the left hand side of the decimal point, we will assign negative powers to the digit on the right hand side of the decimal point. Let's illustrate this with example 1. This is my decimal point, and on the left of my decimal point I have 0, 0, 1, while on the right of my decimal point I have 0, 1, 1. I'll begin by assigning positive powers to the digits on the left of my decimal point, beginning from 0. So this will be 0, 1, 2. While on the right of my decimal point, I will assign negative powers, beginning from -1, -2, -3. This is the first step. The second step now will be to expand this by using each digit to multiply the base raised to the power of the power assigned to the digit. This will be equal to 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 0 times 2 to the power of 0. Ignore the decimal point and just continue, plus 0 times 2 to the power of -1 plus 1 times 2 to the power of -2 plus 1 times 2 to the power of -3. Now we'll simplify the expression further. 2 to the power of 2 means 2 times 2, which is 4. Therefore we have 1 times 4 plus 0 times 2 to the power of 1 means 2 plus 0 times 2 to the power of 0. Remember, in indices, an index with a power of 0 will always give you 1 plus 0 times 2 to the power of -1. Now for this, I refer you back to the law of indices, the law of negative power. The law says that if my index has a negative power, it is the same thing as saying 1 over x, that is the base, raised to power the exponent or the power m. More like the minus here turns into 1 divided, while you are left with just the base and the power m. If we apply the same law here, it means that 2 to the power of -1, the minus will become 1 over, then 2 to the power of 1, 2 raised to power 1, plus 1 times 2 to the power of -2. The minus here again will become 1 over 2 to the power of 2 plus 1 times the minus here again will become 1 over 2 to the power of 3. Now we'll simplify further. 1 times 4 will give us 4. 0 times 2 will give us 0. 0 times 1 will give us 0. 0 multiply anything is always 0. And here we have a whole number multiplying a fraction. The whole number will multiply just the numerator of the fraction. So 1 times 1 will be 1 over 2 to the power of 2. Remember, 2 to the power of 2 is 4. Plus a whole number again multiplies a fraction. It will only multiply the numerator. 1 times 1, that will give us 1. And 2 to the power of 3 will give us 8. If we add up all the whole numbers, 4 plus 0 plus 0 plus 0 is still 4, plus 1 over 4 plus 1 over 8. The next thing to do now will be to add the fractions together by finding LCM. LCM of 4 and 8 is 8. 4 will go in 8 2 times. We use the 2 to multiply the 1 here, so that will be 2 plus 8 will go in 8 once. We use the 1 to multiply this 1. 1 times 1 will give us 1. We will therefore have 4 plus 3 over 8, which is the same thing as 4 whole number 3 over 8 base 10. So this will be our answer in base 10. We can also write this answer in decimal. That will be 4 point. If you divide 3 by 8, you will get 0.375. 375. So our answer will be 4.375 base 10. This is how we convert a decimal number in any given base to base 10. Example 2. Let's take this away and move to example 2. Now for example 2, we go through the same process again. Remember, the first thing to do, identify the position of your decimal point. Assign positive powers to the left of your decimal point, beginning from 0. So you have 0, 1, 2. Assign negative powers to the right of your decimal point, beginning from -1. We have only one digit to the left, just -1. So the next step will be to expand this by using each digit multiplied by the base raised to the power assigned to the digit. So this will be 2 times 3 raised to power 2 plus 1 times 3 raised to power 1 plus 2 times 3 raised to power 0 plus 2 times 3 raised to power -1. We'll simplify further. This will be 2 times 3 to the power of 2. That's 3 times 3, which is 9, plus 1 times 3 to the power of 1 is just 3, plus 2 times 3 to the power of 0. That will give us 1, plus 2 times 3 raised to the power -1. That will be minus. The minus here becomes 1 over 3 raised to the power 1. That's 3 raised to the power 1. If we simplify this further, 2 times 9 here will give us 18. 1 times 3 here will give us 3. We have plus 3. 2 times 1 here will give us plus 2. Then plus a whole number now multiplies a fraction. Remember, it multiplies only the numerator of the fraction. That will give us 2 over 3 to the power of 1 is 3. Now if we add the whole numbers together, we have 18 plus 3, that is 21. 21 plus 2 will give us 23 plus 2 over 3, which is the same thing as 23 whole number 2 over 3. Again, we can write our answer in decimal. In decimal, the answer will be 23.666. We put dot dot dot, indicating that the decimal has not terminated. Or a much more presentable way of writing this is to use what is known as a repeater. So we write 23.6 and put a dot on top of the 6. The dot indicates that the 6 is repeating, and that's why it is called a repeater. So this is 23.6 with a repeater, and that is the answer in base 10. My last example for today before I leave you to solve the remaining 2 examples. We'll look at example 3. We have 1b.2 base 13. We go through the same process again. Identify your decimals. Assign positive powers to the left of your decimal beginning from 0. Assign negative powers to the right of your decimal beginning from -1. Then go ahead and expand. This will be 1 times 13 to the power of 1. 1 times 13 raised to power 1 plus b. Remember the letter b. Letter A is 10, letter B is 11. 11 times 13 to the power of 0 plus 2 times 13 to the power of -1. And that will give us 1 times 13 raised to power 1. 13 to the power of 1 is 13. 13 to the power of 0 is 1. Then this will be 2 times 1 over 13 to the power of 1. And if we simplify further, 1 times 13 is 13. 11 times 1 is 11. 2 times 1 is 2 over 13. and this will give us 13 plus 11 is 24, whole number 2 over 13 base 10. This will be our answer for question 3, which we can again write in decimal. If we write that in decimal, that will be 24.153846 dot dot dot. In other words, the decimal has not terminated and it's not repeating, so we cannot use a repeater in this case. The decimal did not terminate and it is also not repeating. So this is how you convert from a decimal number in any given base to base 10, my friend. I'll see you in the next video.